Today we are going to start chapter 9, Parametric Equations and Polar Coordinates. In this chapter, we are going to go over plane curves and the definition of parametric equation and how do we graph the plane curves. And also how do we use parametric equations, find the slopes and the stuff related to calculus. And arc length formula and the vectors, velocity, position, and the acceleration. Polar coordinates and the polar graphs, and the difficult part will be the polar areas of a curve and the polar areas between curves. Today we are going to go over 9.2 plane curves and parametric equations. So what is a parametric equation? Definition. Given f and g are continuous functions of t, and x equals f of t, y equals g of t is what we call the parametric equation. And t is what we call the perimeter here. So when we plot this, and the points x, y will give us the plane curve. Let me have a look at the example 1. So make a table of values and sketch the curve indicating the direction of the curve and eliminate the parameter. So x equals square root of t minus 1, y equals t plus 2. This is the parametric equation. When we make a table, so this is t, this is the point, our input is t, our output is xy. So given t, as we know, t has to be greater than 1 here. So t equals 1, 2, 3, 4, 5. At t equals 1, so this is 0, 3. So t equals 1 is 0.03. At t equals 1. T equals 2, which is 1, 4. T equals 2, 1, 4. And t equals 3, square root of 2, 5. Square root of 3, 6. Square root of 4, which is 2, 7. So 5, 6, 7. So if we connect all these points, and this is the direction as t increases from 1, as t keep increasing the direction of the curve. How do we get rid of t and find the rectangular form? So from equation x equals square root of t minus 1, so we square both sides. So t equals x squared plus 1. We plug t into the second equation, so y equals x squared plus 3. And this is what we call the rectangular form. For this problem, x has to be greater or equal than 0. So the big picture is we just need to solve for t and trying to get rid of t, plug it into another one. Let's have a look at how do we use graphing calculator. So when we use a graphing calculator, we just need to change the mode to parametric equation, and then input the xt, y of t into the function, and the graph will look like so we change the mode to parametric here, done, and put this in, the function in, and click graph. It will look like something like this. It's very similar to an ellipse. So now you can click the trace button on your calculator. It will give you a point, and if you keep pressing the right arrow, hold it, and it will give you the direction. So the direction will be at 5, 1, 2, 3, 4, 5, negative 1. So the direction should go counterclockwise. Given rectangular equation, how do we find a parametric equation? We have different ways to express the same rectangular equation. For example, we set x equals t, y can be 4t squared minus 1. If x equals square root of t, y can be 4t minus 1. X equals sine of t, y equals sine t squared minus 1. So these are parametric equations. Of course, we have infinite solutions. So given this practice problem, how do we get rid of t and write this equation into the rectangular form? From first one, cosine t equals x over 5. sine t equals y over 3. Based on the property, cosine squared plus sine squared equals 1. So I have x over 5 squared plus y over 3 squared equals 1. This is an ellipse. So how do we graph this one into the calculator? We set up the mode to parametric form, put this in at t equals negative. Make sure you set by your window t from -2 to 3. So when t equals -2, x equals -1, x equals +1, y equals -4. And the graphs briefly look like this. Now, after you have the graph, you press trace, click trace, and then press the hold the right arrow button. Okay, and you will see the trajectory. This is the direction.